Okay, today we're going to be talking about section 5.4, which is synthetic division. So synthetic division is actually a shortcut for long division. Whenever I say it's a shortcut for long division, let's talk about what long division looked like. So long division would look exactly like saying 8,327 divided by 4. In grade school, you would pop the 4 out, and then you'd have 8,327 on the top, on the inside. 4 goes into 8 2 times, multiply on the diagonal, and then you would subtract to give you 0. Then you would drop this 3 down, and then you'd say again, how many times does 4 go into 3? Then you would say 0, then you would drop down the 2. How many times does 4 go into 32? 8, so multiply that by 4. That gives you 0, and drop down the 7. And then how many times does 4 go into 7? Once, and then I'd have a remainder of 3. And you would have just put remainder of 3. So 2,081 remainder of 3, or you may have written this as 2,081 with 3 over 4, okay? So what we're going to be doing today is we're going to be doing a shortcut for long division, because nobody likes to do this. This is not very much fun to do. So what this means is synthetic division is a shortcut for long division and can be used only when you are dividing by divisors of the form of x minus k. Now this means that you're dividing by a degree of 1. What do I mean by that? That means it's x to the first power there. Okay? Now the factor theorem says this. If f of k is equal to 0, then f of x has a factor of x minus k. Meaning if your remainder is equal to 0, then you are a factor. Now, an example, the very first thing that you have to do whenever you look at this thing is you are going to count your powers, and those are going to be your exponents on your variables. And you want to make sure that you're not missing any of them. So degree 3, degree 2, degree 1, and degree 0. Now, if you are missing one of them, then you have to put a 0 placeholder there representing the value that is missing. So the very first thing we're going to do is we're going to take this part right here, which is what we call the divisor. And we're going to set that divisor equal to 0. X is equal to 5, and this 5 is what we're actually going to divide by. So I'm going to make a half box, and in that half box, I am going to put the number 5, because that's what we're actually dividing by. We are dividing by the expression x minus 5, but what we're actually dividing by is the number 5. At this point, you then are going to grab only the coefficients with the sign to the left of them. Only the coefficients with the sign to the left of them. Okay? So I'm going to equally space these out with the number 3, negative 17, 15, and negative 25. Okay? Now, we are simply going to drop down the number 3. When we drop down the number 3, just like in long division, we are going to multiply on the diagonals. So 5 times 3 is going to give us the number 15. Then I'm going to add straight down. Negative 17 and 15 gives me a negative 2. Now again, on the diagonal, we are going to multiply. So if I multiply on the diagonal this time, I'm going to have 5 times negative 2, which is going to give me a negative 10. Then I'm going to add on the vertical, giving me a 5. And then again, I'm going to multiply on the diagonal to give me a 25, and then add straight down, and that gives me a 0. What I just showed you is that since my remainder is a 0, then x minus 5 is what we call a factor of the given polynomial of 3x cubed minus 17x squared plus 15x minus 25. So how would I write that? Well, as soon as you do synthetic division one time, you are going to drop the degree of this polynomial down from a 3 to a degree of 2. So that means we're going to have a 3x squared minus a 2x plus 5. And that is going to be the equivalent polynomial that we would use if we were doing long division. Now, long division is not something we're going to be working on, so we're going to focus just primarily on synthetic division. So this is your first example. Second example, same exact philosophy. However, you can clearly tell that I am missing powers. So we are going to rewrite this problem. So this problem is going to be 5x cubed then I am missing a power of x to the squared. So I'm going to put a placeholder of 0 there. Then I'm going to drop down the 6x. Then I'm going to drop down the 8. So now I have 3, 2, 1, 0. And I'm going to recopy the rest of the problem. I am no longer using the original problem. I'm going to be using this problem. At this point, I come over to the right-hand side and I look at the x plus 2. And I say the x plus 2. What do we know about that? We know that I need to take this value and set this equal to 0. And that's the value that's going to go in my half box. So that's equal to -2. So I put the -2 in the half box. And I'm going to drop down only the constant terms, including the 0 and the coefficients. So I'm going to have a 5, a 0, a 6, and an 8. I drop down the 5, and then on the diagonal, I multiply to give me -10. I add straight down to give me -10 there. Then on the diagonal, I multiply to give me a +20. Then I'm going to add straight down to give me a 26. And then after that, I'm going to go on the diagonal again to give me -52. Sorry. And then I'm going to add straight down to give me a -44. This is what we call our remainder. Since my remainder is not 0, what this means is x plus 2 is not a factor of our original polynomial of 5x cubed plus 0x squared plus 6x plus 8. It is not a factor. So how would I write this answer? Well, as soon as I do synthetic division one time, the degree or the power of this polynomial goes from being a 3 down to a 2. And I simply put the variables back on with the coefficients of 5x squared minus 10x plus 26, and then I say r for remainder, -44. And then this is done. Okay, let's do it again. Very first thing we're going to do is we're going to say, okay, let's check for our powers. This is a 3, 2, 1, 0. I am not missing any powers, so I'm good with that. So I'm going to come over here and I'm going to take this x plus 1/2 and set that equal to 0. What goes in my half box is going to be a -1/2. So I draw my half box, putting -1/2 in there. I drop the 4, the 16, the -23, and the -16. Remembering that the signs go with the numbers. The signs to the left of them go with the numbers. And from there, I am going to drop down my 4. A positive times a negative is a negative, and half of 4 is going to be 2. I add straight down. Sorry, I forgot to drop that 4. I add straight down, and I'm going to be getting a 14. A positive 14 times a negative is going to give me a negative outcome, and half of 14 is going to give me a 7. I'm going to add straight down. That gives me a 30. A double negative creates a positive, and half of 30 is going to be 15. And then I'm going to add -16 to that to give me -1. And what I just found is that since this is my remainder and it's not 0, it is not a factor. However, how do I write this answer? Well, I'm going to look at the highest exponent and I'm going to say, okay, the highest exponent that I had in the original problem was degree 3, so I'm going to go down 1 unit to make that degree 2. So that means what I have left is 4x squared plus 14x minus 30 with a remainder of -1. Okay? Now, the next thing we're going to talk about is what we call the remainder theorem. Before we do the remainder theorem, if you would have seen this previously, q of x is this polynomial, and I want to know what q at 3 is. Well, we've done evaluation many times. All this is a simple evaluation problem where you are taking the function q of x, which represents this right here, and every place you see an x, you will plug in the value 3 in its place. Give me 2 times 3 to the 4th power minus 3 to the 3rd power plus 2 times 3 minus 1. So what that means is if we go ahead and we go to Desmos and we plug this in, I would type 2 parentheses 3 raised to the 4th power, and then minus parentheses 3 raised to the 3rd power, 2 times 3, and then minus 1. And I did not type that in. This should be a plus. And that's going to give you 140. So what this means is this answer is 140. Now, we did that the old-fashioned way of doing plug and chug. Well, what if I told you that synthetic division gives you the answer right away? Meaning, when you do synthetic division, the remainder is actually the evaluation of that number. So what do I mean by that? Well, we're going to come down through here and we're going to say, am I missing any powers? 4, 3, I am missing a 2. So I need to rewrite this thing to be q of x is equal to 2x to the 4th minus x cubed plus 0x squared, because it is missing, plus a 2x minus a 1. That's what I'm going to use for my synthetic division. So now in my half box, I'm going to put the value 3, and I'm going to drop down the coefficients, including the 0 and including the sign to the left of it. I drop the 2. I multiply on the diagonal. That gives me a 6. I'm going to add straight down. That gives me a 5. Then I'm going to multiply on the diagonal. That gives me 15. I'm going to add straight down. That gives me 15. 15 times 3 is 45. Plus 2 is 47. And 47 times 3 is 141. Add a negative 1 to that, and I'm going to get 140. That 140 looks very familiar. That 140 is our remainder, but it is also known as our Q of 3. Our Q of 3. That's the beautiful thing of this value. So, your answer of Q at 3 is actually 140, and this is how you are going to do tonight's homework. You are not going to do this. Do not do this. I do not want you to plug and chug on your homework. What I want you to do is to do synthetic division and show me what the remainder is, and that remainder will be equivalent to it. So here we go. Use synthetic division to evaluate the function at the indicated value. So what we're going to do is we're going to check for anything that we are missing. 6, 5, we're missing, so we're going to rewrite P of x. So P of x is going to be 1x to the 6th plus 0x squared minus 4x to the 4th. I'm missing a power of 3, so that's 0x cubed, plus 3x squared. I'm missing a 0x plus 2. That's my polynomial. And I want to evaluate it at negative 2. Negative 2 goes in my half box, and I have a 1, a 0, a negative 4, a 0, a 3, a 0, and a 2. I drop down the 1. 1 times negative 2 is negative 2. I add straight down to give me negative 2. Negative 2 times negative 2 is positive 4. Add straight down to give me 0. 0 times negative 2 is 0. Add straight down to give me 0. 0 times negative 2 is 0. Then we're going to go ahead and add 3 and 0 together to give me 3. 3 times negative 2 is negative 6. Plus 0 is negative 6. Negative 6 times negative 2 is 12. And 12 plus 2 is 14. 14 is what we call our remainder. And that also tells me that P at negative 2 is equal to the value 14, which is exactly how I want you to do tonight's homework. One more example. The last example I want to do is it says use synthetic division to evaluate the function at the indicated value. So different problem, different value. So check your powers. 5, 4, 3, 2. Ooh, I'm missing a 1. So I need to rewrite my P of x. So P of x is x to the 5th minus 4x to the 4th minus 2x cubed minus x squared plus a 0x plus a 2. I'm no longer using this one. Now I'm going to do 3 in my half box. I have a 1, a negative 4, a negative 2, a negative 1, 0, and a 2. Remember, you are dropping the signs down with the numbers that are to the left of them. So I drop down the 1. 1 times 3 is 3. Negative 4 and 3 gives me negative 1. Times 3 gives me negative 3. Add straight down. That gives you a negative 5. Multiply diagonally. 3 times negative 5 is negative 15. Add vertically. That gives you negative 16. Negative 16 times 3 is going to give you a negative 48. Negative 48 plus 0 is negative 48. And then lastly, you are going to have negative 48 times 3. 8 times 3 is going to be 24. Carry the 2. 12, 13, 14. Negative 144 to give you negative 142. So what this means is P at 3 is going to be the value of negative 142. Tonight's homework is going to be 5-4 worksheet 1.